It's my pleasure and honor to invite our final speaker for the day, Mr. Manoj K. Sundaram. He is Head Business Development Industrial Quality Solutions, Zeiss. Manoj works with product verticals and marketing groups of Industrial Quality Solutions division in India, supporting technical sales for varied applications. He has spent more than 2 decades in various positions covering sales, service, and product management. His competency is in coordinate measuring machines, optical machines, surface and form geometry. He works with Indian automotive and auto component industry to deliver products, technology, and last-mile solutions in dimensionals and form metrology has been the strength of his career. As Head of Business Development, he's working on positioning Zeiss solutions in electric vehicles, aerospace, and electronics manufacturing. I now invite Manoj for his presentation.
Good afternoon, everybody. Vanakkam, Chennai. Maybe that's the way to start. Lovely speakers, lovely dais, and was really great to know the gentleman, Dr. VK. I somehow never crossed paths or knew about him, so it was really great to know about him. I'm really jittery after such speakers, extempore, talking wonderful things, and I was in rapt attention that I didn't even switch on my laptop before coming here. We are, as you saw, my profile, that I have been all along in sales and marketing and also application engineer and so on. I've worked extensively in Chennai with auto OEMs, auto component companies and so on for the last 2 decades. So my presentation is going to be more of what we call as I will provide you with some new tools and techniques which have come in the industry, which will probably lead, which will enable I believe most of you are in manufacturing, auto component manufacturing, trying to see where to go. So some of the tools will help you to go faster in your industry. Zeiss is a name which is associated with quality and reliability for a very, very long time. The topic given to me was emerging trends in quality and metrology and in metrology. Right. Okay, I'll give a briefing of the company, how Zeiss as a company touches the lives of each and everyone in the floor and also your family members and so on, how we are connected to you by various means. But before that, I will delve myself into the presentation. So what are the trends which are emerging as the business focus is shifting in the last 2 to 3 years more so? We are moving away from IC engines to electronics manufacturing. In Tamil Nadu is also in the forefront of that. Electric vehicles, what you see in the center. Windmill, again, Tamil Nadu is leading player in the windmill area. Additive manufacturing, I was happy to know that Subrata Forge and Murli sir is also into it. Aerospace and so on. So these are some of the areas which are shifting, and Zeiss has been predominantly in the IC engine space in Chennai. And these businesses, new businesses, provide with new problems. Electronics gives you an idea of high volume, high speed. It's unbelievable the kind of, the volume of measurements, what is required in one mobile phone. You must go there to see, to believe it. Complex micromechanical issues. If you talk about electric vehicles, I think the speakers spoke about cell safety, energy retention, motor performance, light weighting. We don't want cars to be heavy. Okay, motor is fine, the motor has to be really light. Talking about additive, powder quality, internal porosity, part verification, and so on. So there are a lot of challenges around the new business areas which are coming up. And let's see whether the old systems naturally may not give you the right solution. So we'll see what are the new things around. Zeiss primarily has 4 methods of measurement. One, contact type, which is the CMMs, which maybe I can ask how many people have used a Zeiss CMM or a Zeiss solution? Okay, so there are a few. Okay, fine. I thought in Chennai there'll be many more. Okay, so we have quite a few systems, contact measurement. So we measure by touching the part. So that's one way of measuring. Second is we can measure by throwing a structured light on top of it, which is the most in thing today. That you can, like a projector, you can throw a light on the part and you can get the data. Third is using an X-ray device. So this is exactly like the CT scan, what somebody spoke about. So you use a CT scan-like device for capturing the data. Or you could also use an electron beam to really find out the high resolution stuff. Now, what does Zeiss do in the space of where I come from, the vertical, is we just measure dimensions. So we don't do anything, we don't do analytical, we don't do chemistry, we are only into dimensional measurement in metrology. So that's our space where we have done quite a bit of work. So this is not a rain map of Chennai. This is a map of our, our install base in Chennai. So this is around 1,000 units of equipment sold in Chennai over the last 25 years, and I wish to thank my team, Arasu and Hari, who are there, who have done a great job. Each circle represents about 30 machines, so you can count it. So that's the kind of involvement we have with the OEMs, Tier 1, Tier 2, and even Tier 3 companies who have trusted us. And believe me, some of these machines are at least 25 years old. They really work, and they work at the level of promise which was delivered in 1995. So that's the level of precision what Mr. Samir kept mentioning, Zeiss is known for. Okay. Moving on, as we were talking about the tolerances have been coming down and down and down, and we are close to zero, we have nowhere to go. You can see, today we have tolerances of 3 microns are very casual and common, roundness of 2 microns or RZ value, the roughness values of 0.2 micron are quite common in the industry. So what next? What's going to come up? If you look at the industrial space, about 80 to 90% of the tasks are into form, size, position, roughness. That's basically shape or dimension measurements. This is a kind of a picture which has been put up by the roadmap for manufacturing metrology for the future. These are about 7 points which are here, which relate somehow to being fast, being accurate, and being safe, and being flexible. So you cannot find one system which would deliver everything. If you take the CMMs, I mean, like the ones which are slow moving, so if you are about to buy a tool in an industry, please use this filter to see whether it is fast, it is accurate, it is safe, flexible, what meets, what kind of gets you closer to a map. This will be one idea. Second is when you look at sensor and measurement companies and look at mechanical engineering companies, there is a data which says that it's better to be in the measurement and the sensor company because they make a lot of money. So it looks like that the manufacturing industry is adopting measurement in a big way. As we talked about fast, there is a clear inference that reducing inspection time is the most critical topic in any manufacturing. Let it be medical, let it be any kind of manufacturing, reducing inspection time is most critical, and it's not possible with the same kind of device. Also, there is a trend that, when new technologies come up, new verticals come up, it is not possible that you have the standards already laid out. There are no standards for battery measurements. There are not many standards for additive. It's still yet to be standardized. So you must be clearly careful where to go. The most important trend which is coming up is, as Sir was speaking about data analytics, a holistic representation, a representation which is good enough for the user. The person who is sitting next to the machine, he should get a good holistic picture of what's happening to his part. Also, you need the lists, numbers, compiled in a nice way so that the management gets an idea what's going on in the machine. So we have tools to cover both, to satisfy the operator and also to satisfy the management. I will skip certain slides. So coming back, so this is the area, and I will pick up 1 or 2 topics to show you what's new in the market. Now, as you know, that electric vehicles are going to move faster. It looks like that by 2030, we would have a decent population of four-wheelers, commercial vehicles, and passenger cars also would be moving up the space. So as we see now, the battery is going to cost about 40% of the car, and electronics will be about 30%. So our business was totally into auto components. Chennai is the Detroit of Asia, as we mentioned. But what's going to happen to these auto component and OEMs in India? How are they going to change over? The parts are going to reduce, so naturally there is a pressure on the auto component market to see how they're going to change gears. This is where we could help you. This was the old story that we had too many parts in a car, and today the number of parts in a car are going to be much less if it is an electric vehicle and it catches on. As Mr. Mukundan also mentioned, we are at crossroads. We don't know which technology is going to pick up. Is it hydrogen fuel cell, or is it going to be the BEVs? But you are in safe hands with Zeiss. We have what we call as the NEV vertical, which is developed, and we have solutions for battery, electric motor, e-control, and fuel cell. The problems are different in every the problems are different in every space. In battery, we have different issues arising out. In e-motor, we have to have aluminum parts, and then lightweighting is a major topic. In fuel cell, you have a lot of micro profiles to be measured. And electronics is another topic which we are catching up. Just to give you an idea of what is the spread of Zeiss, you can see on the top line, you can see that there is a scale of centimeter, millimeter, micrometer, and nanometer. So you just pick up one battery. It could be a simple AAA cell. What is shown here is a prismatic cell. So we could measure the macro element of the cell, the weldings, and so on. We can move down into X-raying the battery, looking at what is the internals. We could put it on a microscope, look into the micron scale of how the battery looks like and what is the damage. We can further keep going down to the nanometric level, what is called the SEI layer, which really decides whether the battery will function or not. The SEI layer is like the weir, we can say, of the battery. So that is a few nanometers or tens of nanometers wide. So we can straddle across from the macro to the micro or the nano. That's the power of Zeiss as an organization with its various verticals. Some more examples out here is what you see is the battery layers in detail with a crack or a damage on it. Electronic components can be inspected without opening it up and looking into what has gone wrong inside. So this will enable people who are developing tools, prototypes, to get faster to the market. Another applications, of course, simple applications like battery, simple applications like water bottle. Also, it is important that it doesn't leak. It doesn't leak, or you develop a new tool. So you would like to inspect. You want to get to the best tool as quickly as possible. Again, coming back to NEV or electronics, the motors have to have a real low resistance so that they can function efficiently. The welding is one key area which can be inspected on an X-ray machine with adequacy. Most of the technologies what I'm speaking about is available at our office in Bangalore and also in Chennai. So I would welcome you to pass on the word and visit us to see how you can take advantage of all these topics. I will share a 1-minute video of what it is. Let's say you are making a part which you have to send it to Austria for a final approval. So if you have a machine like a Metrotome or an X-ray machine, it's very easy for you to put the part inside as a whole, as a complete assembled unit. The part would be X-rayed, and all the details of the part, including the external, internal dimensions of the plastic, metal, bulb, whatever is inside, would be picked up, and we could do the complete GD&T, what is required to qualify the part before you ship it out to your customer. So this kind of a technology really takes you forward, and of course we would like that you all buy these machines. But looking at the ecosystem, we have put these machines in most of our quality centers, where engineering services people who are into development in TCS or other areas, they can visit us and they can get their parts measured. They can quicken their development cycle. I think I will be short of time, so let me skip. So it's not only applicable to an engineering product, it's applicable to a Kinder Joy. So if you would like to see Kinder Joy after shipment, when it reaches the end distributor, how is the tool inside, that could be easily seen. And you could take some corrective action to see whether things are okay, and you could slice out only the different metals or different plastics and see if things are fine in it. It's a fabulous tool for use. And as we said, speed, yes, if you have a, like in a CT scan, nobody does a full body CT scan, you know if there is a problem at some location. For example, in the engine block out here, you want speed because you want to match to the production speed. Then you can decide what to check in the engine block and you can move it faster. So this is one tool which is available. Please come to us and we could give you a solution. Second is on additive. Okay, 3D printing is an upcoming topic and this is a case study. We have a tool which the supplier is dead, so we just have the drawing. So from the drawing we create the tool, we do a 3D printing. It's a wonderful technology which can improve the design thinking, or what we call, what Mr. Venkat said. And once the tool is ready, now I would put this on the next Indigo flight to fly, and how many of you will be willing to sit in it if it is not qualified? So qualification is of primary importance, and the qualification, it calls you to get into multiple missions to do the qualification. So this, because you cannot inspect what is inside. So those are the challenges, so we have to take it through multiple missions. But finally, once you take it to multiple missions, we have a wonderful data set, and we can combine all of the data set together to qualify the part from outside. Then we can use our tool to get inside. This is applicable for medical, this is applicable for any manufacturing requirement. You can get to inside, you can measure the dimensions, you could measure the GD&T, you can see if the fluid holes are filled or free, and it doesn't stop there. You could go deep inside to look for defects in the additive manufacturing cycle. If there is an unwanted element, a high or a low porosity, or an unwanted element available over there. So all the data sets from many equipments can be combined together to give you a solution. Again, this set of equipments are available with us at our office. Okay, I will just move on over this, I'll skip these things. So there are optical solutions available today to do the same job in a faster way. As you could see here, this is a battery tray, a fabricated battery tray, and it is not measured by a CMM, it is measured using optical systems. So they can do the same thing at about 1/10 of the speed. I'll again move on, we can watch all these videos. Okay, let's look at medical devices. Now somebody wants to develop a medical device for inhaler for a medical supplier. Now, how do you know the inhaler is working fine? It has a lot of micromechanics inside. So a full inhaler without destruction can be put inside our machines, and you could get the complete data thereon to do a PPAP approval or to be very sure of what is going on. So the complete inner structures can be analyzed beautifully. Again, another example of medical device. So if you guys, your friends are into development and they want to speeden it up, talk to us, we'll be able to give you a solution. Okay, skipping these things. Okay, we have other solutions in the auto component market. I put in all this, but I will skip all these topics. We have solutions all around using microscopes, which we will not use. So basically, we provide tools to help quality, and we have been doing it consistently for, can somebody read out the number of years? 175 years. It is not a joke. It is quite serious that a company has existed for 175 years, and it is a very, it's not a public limited company. It is a very innovative firm. Our core message is that we want to make you see beyond. See beyond things what you cannot normally see. We started it with the first microscope in 1857, and today, if you see, we invest about 13% of our revenues back into R&D, by which we maintain a cutting edge. Now, coming to the last question of how do we touch your lives, your kids' life, your grandchildren's lives? If you can go through one statistic which is in the middle, 80% of the microchips worldwide, whether it is a USB stick or a mobile phone or any of the electronics devices, 80% of the chips are done on a Zeiss machine. So that's the level of control or the quality what we have. I have one more minute. So what we are into is one of our vertical is into what is called the semiconductor lithography. in which we enable the smaller, more powerful and energy efficient microchips. So if you are able to communicate with 4G, 5G and discuss, we have a role to play there. This is how the chips are made, and the most important thing is the imaging area, where you have 1 billion transistors to be put on a space of 5 by 5 millimeters. And that's what we do using some of our beautiful optics. The one you see in the middle is optics of 6-foot optics, each costing about $1 billion, and that is what we make to make the world go round. Just to give you an idea, how good are these optics? What is the quality of these optics? Okay, there are three things here. One is the optics. Second is you have some space mirrors. Third is you have a household mirror. Now, if you expand the optic, which is of the size of 300 millimeters, to fill the whole of Germany, you expand it about 5 lakh times, then you would find the error in the z-axis of 0.1 millimeter, 100 microns. That's the level of precision what we are putting into this optics. If you compare it to the space mirror used in astronomy, it's about 2 centimeters. A household mirror will be very bad, about 5 meters. So this is a level of precision what one of our vertical goes on and on doing for the last 20 years, and that's how the offshoots of those technology are used in all other topics. And we have been supporting the world right from the moon landing to PCs to internets to smartphones, and what we discussed with Hyundai and everybody about ADAS, autonomous driving. Autonomous driving would involve a lot of data processing, and data processing means you need good chips, powerful chips, light-weighted chips and less energy consumption chips, and that's what we do at Zeiss. Also, many people are into, if you're into hunting, if you're into bird watching, then please talk to us. We have some wonderful stuff to give you. Thank you very much. That's what I had to present. Thank you.